In this video, I'm going to show you how to build a simple rock, paper, scissors game in Python. As a sneak preview, here's a look at what the final product is going to look like. The program will ask the user to pick either rock, paper, or scissors and show the result. So for example, here I choose rock and the computer chose scissors, so I win, and it updates the score to 1-0. Next I'll choose paper, and now the computer chose scissors, so I lose, and the score is now 1-1. And we'll be able to keep playing, and the program will keep track of the score. We'll also make it robust enough that it'll be able to handle both uppercase and lowercase letters, and we'll even be able to handle cases where the user accidentally enters some white space. Lastly, we'll be able to quit the game by just typing in end, and the program ends. So first, we'll implement some basic program functionality. Now, the computer's decision in the game should be random, so I'll import the random module here, and I'll use random.choice to randomly generate either rock, paper, or scissors. I'll assign the result to a variable called computer since it's the computer's choice. Next, we need to get the user's choice, so I'll use the input function and ask the user to input either rock, paper, or scissors. Now that we have both players' choices, let's write out the three possible cases, which are a tie, the user can win, or the user can lose. Let's start with the simplest case. If both the user and the computer pick the same thing, it's a tie. So here we'll write if user equals computer, and we'll print out a message. I want to actually display what the computer chose, so f strings, which are like template strings, will come in handy here. We're writing from the computer's perspective here, so I'll say I chose, and then we'll put whatever's in the computer variable here, so that goes in the curly braces. So this won't actually print out the word computer, but we'll pull in the value of the computer variable. Then we'll say it's a tie. Next is the case that the user wins. Now, because the user can only pick 3 different options, there are only 3 different cases where the user can win. So we'll say else if, or elif in Python, the user picks rock, then the computer has to pick scissors for the user to win. If the user picks paper, then the computer has to pick rock. And if the user picks scissors, then the computer has to pick paper. So if any of these 3 conditions are met, then the user wins. So we'll print out a message, again using f strings, saying I chose, then whatever the computer's choice was. You win. Now for the last case, we actually don't have to list out all the losing cases because we already covered ties and we covered all the winning cases. So if we get to this part of the program, we know that the user has lost. So we can just make this last part an else and just print out a message saying I chose computer. You lose. Now let's test it out and see the results. Let's pick rock first. Looks like the computer chose scissors, so we win. Let's try paper. And the computer chose rock, so we win again. Now, how about scissors? Nice, we won again. Let's see if we can get a loss or a tie. Okay, now we both picked rock, so it's a tie. And now I'll pick paper, and the computer chose scissors, so we lose. Now, in reality, we don't want to restart the game every time we want to play. Instead, it would be helpful to have the game continue running until we want to stop playing. So the way we'll do this is by putting the entire code inside of a while loop. Let's have the user end the game by typing end. So our condition for continuing the loop will be while user does not equal end, and we'll put everything inside of this while block. We also need to make sure we define user before the condition is evaluated, or we'll get an error. So I'll just initialize it to the empty string to make sure that this runs at least once. Let's also print out a message before the loop starts, letting the user know how to quit. So we'll say quit anytime by typing end. The last thing we need to do is include a case for when the user types end. So we'll say if user equals end, then just print out a message saying goodbye. We also want this to be connected to the other cases, so I'll change this to an elif. So now if the user types in end, this condition will be true, so the program will print goodbye, and when it goes to the start of the loop, this condition will be false, so the program will just end. Now let's test it out. I'll choose rock, looks like I win, and the program will continue asking me for my input. So I can keep playing and choose paper, then scissors, and so on. When I want to stop playing, I can type end, and the program will say goodbye and end. Our program works pretty well, but there is a problem here. Let's say I'm playing and I decide to choose hammer, which isn't a valid option. Instead of rejecting my input, the program just goes ahead and says I lost. In fact, I can put whatever garbage I want in here, and the program will always say that I lose. Why? Well, if the user puts in something invalid, it won't be equal to N, so this condition is false. It can't be equal to the computer's choice, since the computer can only generate rock, paper, or scissors, and it can't be any of these conditions either, since the input isn't rock, paper, or scissors. So we end up just going to this else block here and saying that the user loses. So let's fix this by doing some error checking. I'll add a case here where we can check for invalid input before the game starts. The user input is invalid if it isn't either rock, paper, or scissors, but another way of writing this is just to use the in operator. So we can shorten this by saying if user not in rock, paper, or scissors, and we'll just print a message saying invalid input. And this part should actually be elif so that it's connected to everything else, and now let's try it out. First I'll make sure that rock, paper, and scissors still work. And now let's try hammer. Nice, so the program recognizes that this isn't a valid option and just says invalid input. We can try putting any random string in here, and the program won't crash or give any incorrect information. It'll simply say invalid input and give another prompt. Now there's still two more problems we have to fix here, and one of them is that our input is still case sensitive. So if a user types rock with a capital R, we'll get an invalid input message. In fact, any capital letters will result in an invalid input. The other problem is that if a user accidentally puts any white space, again, we'll get an invalid message. And this is because right now, the user input has to exactly match the cases that we've written in our program, including capitalization and white spaces. So to solve this problem, we'll manipulate our input a bit so that our program will be able to handle these things. First, I'll use the lower method, which turns the entire user input into lowercase. Then I'll use the strip method, which removes all leading and trailing white spaces. Now we can actually just chain these two methods together, so this here means that first we'll turn everything into lowercase, then we'll strip white spaces. Now we can actually take it one step further and just chain the whole thing here and do it in one line. So it's up to you if you want to do that, but I'm going to keep it separate since I think the logic is a bit clearer. So first we get the user input, then we process it. Now let's try it out. If we put rock with a capital R, it accepts it and gives us the result. We can put any number of capital letters now, and our program will still work. We can also try adding leading white spaces, trailing white spaces, and any combination of the above, and the program will properly parse the input. The last piece of functionality that we'll include is the ability to keep track of the score. So I'll create two new variables to keep track of the score. User score, and set that to 0 initially, and computer score, which will be 0 as well. If the game is a tie, then the score doesn't change, so we don't have to do anything. But if the user wins, then we'll increment user score. And if the computer wins, then we'll increment computer score. The last thing to do is to display the score at the start of every round. So here, again, F strings will come in handy. And I'll display the user score first, then the computer score. Now let's test it. So the starting score of 0-0 gets displayed in the beginning. Let's try rock. And we lose, so the score gets updated to 0-1. Now we win, so the score is 1-1. We win again, so it's 2-1. And we win again, so it's 3-1. Now it's a tie, so the score doesn't change. So now we can keep playing as long as we want, and the program will always keep track of the score. The last thing we'll do here is more of a design thing and doesn't affect the functionality, but right now our program is just one big blob. It's a short program, so it works fine, but as programs get longer and more complicated, it spirals out of hand pretty quickly. So usually you want to divide your program into functions, which will make your code cleaner and make the logic easier to follow. Now usually the standard is to put everything inside of a main function. Python doesn't require this, but many other languages do, and it's generally considered best practice, so let's do that here. And at the bottom, we'll write if _name equals _main, then run the main function. What this basically means is that unless this program is being imported as a module, just go ahead and run main. Now where else could we group some work into functions? Well, this part here, where we list all the winning cases, kind of clutters up our code, so this is a good candidate. What I'll do is take all this logic and move it into its own function. Let's call it user wins, and we'll pass in the user's and the computer's choices. Then we'll figure out if the user has won, and if they have, we'll return true, and if not, return false. Then over in the main code, we can simplify this by just saying if user wins, and pass in the two choices. If this returns true, then this part will execute, and if not, then it'll just move on. Now our main code has been decluttered a bit, and we can stick to high-level logic in the main function and leave all the implementation details to the helper function. Now another good candidate for a separate function is the user input section. Again, we can move all these details of how we get and manipulate the user input into its own function. So I'll take this part here and move it into a function called getInput. This function will get the user's input, process it, and return the properly formatted string. Then over here, we can simplify this to say user equals getInput, and all the details are taken care for us in the helper function. And if in the future we needed to do more input processing, we can just add it to that function without cluttering the main code. Now if we test it, we can see that the program still works the same way, but now our main function is a lot more concise and leaves implementation details to its helper functions. And that's about it. We have a fully functioning rock, paper, scissors game that keeps track of the score and ends when the user types end.